Okay, so today, 2.10, we're talking about percent change. Now, percent change just wants to know how much we're going from one thing to another. Super easy. Everything's going to follow this formula today. We're going to do the absolute value of original minus the new, close my absolute value, divided by the original, and then times it by 100 to make it a percent. All right, so here's example number 1. They're going to tell you that the original value, let's say, was 550. The new value is 570. I want you to find the percent change. All right, so we're going to start with absolute value, original, which is 550, minus the new, which is 570, divided by the original, 550, and we're going to times it by 100. All right, so the top line, 550 minus 570 is negative 20, but it's an absolute value, so it's positive 20. We're going to take 20, divide by 550. I don't have a calculator. That would help. Yes. All right, we get 0.036. We're going to times that by 100, and we get 3.6%. So here's the only other thing I need you to do as we do these problems. Did this number from original to new go up or down? It went up, right? Right. So this is actually called an increase. Instead of writing out increase, I'm going to ask you that you just put an arrow pointing up. If it was a decrease, I'd ask you to put an arrow pointing down. Tough one. All right, here's... There wouldn't be a percent change then, would there? Yes. All right, how about this one? If I say the original was 230, the new is 215. Find percent change. All right, so again, absolute value, original, which is 230, minus new, which is 215, divided by 230, then we're going to times it by 100. So we have 230 minus 215, it's 15, divided by 230. Thank you. 0.0652 times by 100. We get 6.5%. Is this an increase or a decrease? Decrease. I'm going to do the arrow pointing down. Right, when you're looking at the original. Yeah, exactly. Okay, so what we are doing right here is what you are doing for problems 8 through 17. Doesn't leave much more, does it? All right. Do we need another example of percent change? Is everybody okay with that? So I'm happy to do one more. Okay. Okay. To find the increase or decrease, you're just looking at the original to the new. So I started here. If I'm going to the new one, did it go up or down? That's it. Yep. Okay. All right, here we go. So after we find percent change, increase or decrease, the next thing I want to talk about is percent error. So we have percent error. Percent error is going to follow this. We have our actual minus the estimated divided by actual, and of course times by 100. Okay? It is basically the same thing. I'm just looking for error. So the way this would approach it, or I guess this is example 3, right? Okay. So maybe you're going to get something that looks like this. You know how sometimes when you go to the fair, right, they have that that one game where the guy's guessing the weight or age or anything like that, right? Okay. So we're going to say that at the fair, this guy is guessing that he estimates my age to be 42. My actual age is 52. Yeah, really. Find percent error. All right, so again, we're going to do the absolute value of actual, which is 52, minus the estimated, which is 42, and we're going to divide by the actual, which is 52, and then times by 100. So we have 52 minus 42 is 10. 10 divided by 52. 0.193, is it? I'll put it 2. I was doing it in my head. I apologize. There we go. 2, 3. Times by 100, and we get 19.2% error. And there's not an increase or decrease when we're talking about error. He's just 19.2% off is all. Okay? This is what you have to do for problems 18 and 19. Huh? Yeah, he could say that I'm, 100%. Oh. All right, let's do one more like this one. Example number 4. Let's say that same guy, since he lost it that one, my kids are with me. We won't use me. We'll use my kids. He estimates their weight to be 150 pounds. The actual is 142 pounds. Find percent error. All right. So again, we do actual, which is 142, minus the estimated, which is 150, and divide by the actual 142, and then times by 100. So you can see, it's important for me to see where you put your numbers in your work today, right? That way I can figure out exactly what's going on. So we have 142 minus 50, or 150 is 8. 8 divided by 142. 0.056 times 100. 5.6% error. So it's pretty easy today, right? Not bad, we're good? Yeah, well, that's what this absolute value is there for. So that doesn't matter which direction it's going, it's always going to be positive, right? That's why that absolute value signs are there. Other questions? That was a good question, Jordan. What else? Anything else, you guys? I'm getting there. I'm getting there. Yes. Okay. Right here, that's why we use an absolute value, so it doesn't matter whether it's positive or negative, it's always going to be positive. I know, this is going to be easy stuff today. All right, so let's keep going. The last thing I want to talk about is in a measurement. Sometimes you can have an error in your measurement and it still work. What I mean by that is, you know how sometimes you're measuring a piece of wood to cut, right? And it can be off by like a 1/16 one way or the other, maybe a little too big, you can pound it and make it fit. Or if it's just a little too small, by a 1/16 of an inch, we can still make it work, right? Just saying. So we can find that measurement that works either way when it talks about measurements. All right? So that's what we're going to talk about next. When we have a measurement error, we can do a max or min on either side to say what's the greatest amount you can be off of and the smallest amount you can be off by for it to still work. Okay? So we're going to be finding a max and min value. All right? Everybody's good so far? Okay. To find this, take the last digit value, and divide by 2. Okay? Then add and subtract from desired length. All right, so let me explain. Let's say I have something that is, I don't know, 162 inches. Okay? So first of all, my 2 falls in the 1 spot. Right? Everybody agree? 162, the smallest digit falls in the 1s. So I'm going to take 1, divide by 2, and it equals 0.5. So now I'm going to take 0.5, and I'm going to add it to my value of 162, which means it can have a maximum of 162.5, and I'm going to take 0.5 and subtract it from 162, so it can have a minimum 161.5. So it would be acceptable anywhere between there. Okay? Let's try another one. Okay, so just a minute. If I have something that maybe measures, let's say 1.6, that is in the 10th spot. So I would take 1/10, divide by 2, and I get 0.05. Everybody still good? I would take my value, 1.6, and add 0.05 to it. 1.65. I agree. And then I would take my 1.6 and subtract 0.05, and I would have 1.55. So again, my measurement could be anywhere from 1.55 or 1.55 to 1.65 and be acceptable. Okay? So let me show you how this actually applies into the homework. Oh, just a minute. All right, so we're on example number 5. And this will cover 20 through 22. All right, Emma? Okay. All right. So it's going to ask you to find the minimum and maximum measurement given the following. That's the directions at the top of the section. And then in the section, it's going to say something like, a dino egg weighs 1.1 kilograms. To the nearest tenth. Find max and min. All right. So I have 1.1, which means I have a tenth. So I take my tenth, divide by 2, and I get 0.05. What am I going to do with my 0.05? Yes, I have 1.1 plus 0.05. Well, it could be 0.5 or it could be 0.005. Depends what your last digit is. Okay? So in this one, I would have 1.15 as my maximum. And then what do I have to do? Yeah, so 1.1 minus 0.05. And I have 1.05 as my minimum. So it should, every time that weight they give you in 20, 21, and 22 should fall right in the middle of your max and min. Right? Okay, so whatever this last digit is sitting in, whatever placeholder that is, and in this case it's the tenth spot, right? We take 1/10 and divide by 2. So I get 0.05. Okay. Awesome question. I'm so glad you asked. So what if it was in the 100th spot? What if we had the same idea and we had 2.37, so it falls in the 100th spot? We would take 0.01, which is 100th, divided by 2, and we get 0.005. So then we would add 0.005 and subtract 0.005. So 2.37 plus 0.005 is 2.375. 2.37 minus 0.005 is 2.365. Or maybe 1. Remember the very first one I did was a 1. There is no decimals, right? Yeah, no, because the last digit you really have is in the ones. Okay, that's a good question. Other questions. This is all the last 3 problems are, is you find max and min, and that's it. Blake. No, this is it. No, not yet. Yeah. Yep, that was it. Jordan. Thank you. You can do that if you want. Absolutely. That's going to help you. Okay, is there any other questions? So I'm giving you 10 minutes. I really believe you're going to get these problems done in 10 minutes. But you need to get right to work to do so. Okay? No, I don't think so. That way I can answer. If we still have questions, I can answer those for you.